dear children of ICSE batch. Okay, I hope you all are doing good and keeping safe. Okay, today we will discuss the 7th chapter in your ICSE chemistry syllabus, that is metallurgy. Okay, at first we need to understand what is this term known as metallurgy, or what is metallurgy. Metallurgy, as you can understand, the term itself has come from the word metal. So in metallurgy we will deal with metals. It is quite obvious. Okay, but what is this metallurgy? This metallurgy is nothing but extraction of metals from their ores. Okay, in metallurgy we discuss about different procedures, different methods to extract any metal from the ore. Understood? So now we have to understand what is this ore. We have to learn few terms, okay, like mineral and ore. To understand these two terms, let's discuss a little on occurrence of metals. That means where metals are found in this earth. Okay, so like maximum metals, as they are chemically active, they cannot stay as only metal. Where when you want some gold, okay, you may not get like free gold, or when you want to get some aluminium or iron, you cannot get a piece of iron in the nature. So how those metals are going to stay? Those metals are going to stay in combination with any other element, okay, mainly oxygen or water. Like suppose if you want to look for iron in this earth, so you will get like one oxide of iron in this earth. You will not get iron in free state. Okay, so you understand that metals like occur in combination with some other element as a compound. These compounds are known as what, children? Minerals. Okay, now coming to the term ore, there are few naturally occurring minerals from where the metals can be extracted easily and profitably, I mean economically. Okay, those minerals are known as ores. In our syllabus we have we need to know the names of ores of 3 metals: iron, zinc and aluminium. So if you are asked to write the ore of iron, the first ore you should write is hematite. Okay, the formula is Fe2O3. Like ferric oxide, okay, or iron 3 oxide, hematite. The spelling is a little like confusing if you do not know it properly. Another ore of iron you can say, that is magnetite, that is Fe3O4. Another ore you have studied in the chapter sulfuric acid while studying about contact process, iron pyrites, FeS2, that is also another ore of iron. All right. Now if we want to discuss some of the ores of zinc, okay, at first we can name zinc blende, that is ZnS. Another ore of zinc is calamine, Calamine, that is ZnCO3, or zinc carbonate. The chemical name is zinc carbonate, but the name of the ore is what, children? Calamine. Okay, now at last we will discuss certain ores of aluminium. Okay, so let me tell you, the main ore of aluminium is bauxite. Okay, and the formula to be written as Al2O3.2H2O, or else what we can say the chemical name, hydrated aluminium oxide. Now in the chapter metallurgy, mostly we need to discuss about extraction of aluminium. So we will discuss how aluminium can be extracted. Okay, and at the very first step, that is the name is concentration of the ore, or we can say purification of bauxite. If you observe the chemical formula of bauxite, I think you can say that this is Al2O3 then .2H2O. That means with the compound of aluminium, some water is also there. What we want to do is, we want to remove this water, we want to remove this impurity. Okay, so how to do it? There are 3 reactions, there are 3 steps to do it. Okay, and this entire procedure of purification of bauxite, or like concentration of ore, is known as Bayer's process. In the first step, what we do is we add caustic soda solution. Okay, So you can see aluminium oxide dot 2H2O plus caustic soda is giving you like sodium aluminate, okay, and water. Now while writing this equation, you must mention the temperature, that is 150 degrees Celsius to 200 degrees Celsius. The temperature must be maintained while doing this equation, okay. So Al2O3.2H2O gives what? 2 sodium aluminate plus 3 water. Then in the next step, what you need to do is you need to add water to get the respective hydroxide. Now if you observe the compound sodium aluminate, you can easily understand it is a compound of two metals, sodium and aluminium. Oxygen is the non-metal present with it. So now if you hydrolysis sodium aluminate, that means if you add water to sodium aluminate, you will get the hydroxide of these two metals. One is aluminium hydroxide and the other one is what? Sodium hydroxide, okay. Now at the last step, what you need to do is, now before I tell you about the last step, let me tell you, in the second reaction, the temperature to be maintained is 50 to 60 degrees Celsius, okay. And at the last step, like the last step is the reaction where the temperature has to be maximum, that is 1100 degrees Celsius. If you let aluminium hydroxide thermally decompose at high temperature, if you heat aluminium hydroxide, you will get aluminium oxide and water, okay. So this is how you can get aluminium oxide from the old bauxite, okay. So I hope you all are understanding like how bauxite can be purified, like actually what happens at the last step, this aluminium hydroxide, it is ignited, okay, to like remove the water so that Al2O3 is only left out. So I hope you understood how Bayer's process work, okay. You must be careful about the spelling Bayer's process, and B must be capital as it is the name of one scientist, okay. Now in the next step, what we do is, like as aluminium is an active metal, okay, we extract aluminium from its compound aluminium oxide by electrolysis, okay. We do electrolytic reduction of alumina, okay. Al2O3 is known as what, children? Alumina, alright. So and the procedure is known as what? Hall-Herold's process, okay. You need to be very careful about these names because in the questions like the name is asked, okay. So if the question comes like in name the following, the process to extract aluminium by the help of electrolysis, what will be your answer? Hall-Herold process, okay. So what we do is we make electrolysis of aluminium oxide, okay. Now see, electrolyte, if you read electrolyte, what is written here? Alumina in molten cryolite and fluorospar, okay. So the electrolyte is not only Al2O3, but along with this Al2O3 cryolite and fluorospar is added, okay. And you can now easily read why cryolite is added. See, it is written cryolite, the formula is also given Na3Alf6, okay, sodium aluminum fluoride acts as a solvent for alumina, okay. Now let's understand this point. Alumina is a very viscous substance, okay. Through that viscous alumina, electricity cannot flow very easily, and like dissociation also does not happen properly, okay. Now so you need a medium so that alumina get dissolved. So cryolite acts as the solvent for alumina, okay. And moreover, see, we are not doing the electrolysis of aqueous solution of alumina here. We are doing what, children? We are doing the electrolysis of molten, okay, molten alumina, okay. Like alumina is molten, that means you have to provide heat, you have to maintain certain temperature to carry out this electrolysis. But let me tell you that the melting point of alumina is 2050 degrees Celsius. The melting point of alumina is 2050 degrees Celsius, but when cryolite is added to it, the melting point of this mixture drops down to 950 degrees Celsius. So it saves a lots of fuel. If you use only Al2O3, then the temperature to be maintained is 2050 degrees Celsius, but if you use the mixture of cryolite and alumina, you need to maintain the temperature only 950 degrees Celsius. Okay, so that is why it is written decreases melting point of alumina and increases conductivity of alumina. Okay, conductivity means like electrical conductivity. Okay, so I hope you understood like why cryolite is added, and as like cryolite you can see Na3Al F6 is there and fluorspar is CaF2, calcium fluoride. So they also get ionized, so mobility of the ions increases and electricity can flow very nicely as number of ions get increased. What I am saying is, if only alumina is electrolyzed, then you are getting only Al3 plus and O2 minus, right? But if cryolite and fluorspar, they also get ionized, then you will get sodium ion, you will get fluoride ion, you will get aluminium ion, of course. Okay, then in fluorspar, as I said, it is CaF2, calcium fluoride, you will get Ca2 plus ion as well. So you can see that the number of ions has been increased. Okay, so electrical conductivity also increases. So I hope you understood like why cryolite and fluorspar are added to the electrolyte. Now let's learn more information. Like, see what happens over the electrolyte. Charcoal powder is sprinkled. Now why this charcoal powder is sprinkled? See, like if you can see that cathode and anode, they are used during this electrolysis are graphite. Okay, so like if charcoal powders are sprinkled, then like heat loss can be prevented. What happens through radiation? As I said, you need to provide some temperature to get this electrolysis happen. Okay, because you need to keep the electrolyte in molten state. That is why like some heat needs to be maintained. But if nothing is sprinkled over like at the top of that electrolyte, then what will happen? Some heat loss can take place. To prevent that, charcoal powder is sprinkled. And one more thing is there, like you can see that at anode the product is oxygen gas, right? And like anode can get burnt in this oxygen gas. Okay, so if that charcoal powders are sprinkled, then that like burning of anode also like can be prevented. All right, so cathode reaction and anode reaction you have to learn. Moreover, you need to discuss the like ionization equation of alumina, that is 2 like Al2O3 reversible 2Al3 plus 3O2 minus. Okay, what I am saying, like Al2O3 reversible 2Al3 plus 3O2 minus. And if you want to write the like ionization of cryolite, how you can write is Na3AlF6 reversible 3Na plus Al3 plus 6F minus. And for fluorspar, as it is CaF2 reversible Ca2 plus 2F minus. So I hope you can write the ionization equation, cathode reaction, anode reaction very nicely, and observe the product at cathode and anode. At cathode, as you are extracting aluminium metal will be deposited, and at anode oxygen gas will be liberated. Okay, so till now I hope you have no problem in the like electrolytic reduction of alumina. After electrolytic reduction of alumina, we need to refine that aluminium. Okay, and that procedure is carried out through electrolysis, and the name of that procedure is Hoops electrolytic refining or Hoops refining of aluminium. The spelling of Hoop is capital H because it is also another name of scientist, as similar to like Hall, Herald and Bayer. So Hoops capital H then double O P E apostrophe S. Hoops electrolytic refining is the procedure to purify like the extracted aluminium. All right, I hope you have understood the extraction of aluminium very nicely. Now we will discuss some part what is there, like some alloys. Okay, like but before I discuss alloys, let me tell you some important questions from this Hall Herald's process. As I told that graphite anodes are used, these graphite anodes are periodically replaced. That means after a certain period of time, that graphite anodes to be replaced. Okay, why these graphite anodes to be periodically replaced? Because as you can notice that at anode, oxygen is being produced, so chances are there those graphite anodes can react with that oxygen. So graphite can be like reduced, okay, because of the reaction with oxygen. That is why graphite like anode should be periodically replaced, okay. And like series of graphite rods are used to increase the like conductivity. All right, so now we have to discuss some alloy, okay. We have like very specific alloys, as you can see the screen. We need to know brass, bronze, duralumin, stainless steel, solder, okay. While discussing these alloys, okay, we need to know their major component and all the components as well. Like brass and bronze, the major component of these alloy is copper, okay. I hope you all know the meaning of the term alloy. Alloy like is like a substance preparing by the addition of like two metals or one metal and one non-metal, okay. And like what are the like advantages of making alloy, okay, because like alloys give you some shiny appearance, and they are like more rigid, okay. They are less fragile than the like component metal. So that is why we like use alloy to make statues and many utensils, okay. Later on I am just like discussing some of the major like uses of alloy. So brass, bronze, okay, there the main component is copper, whereas brass is made up of copper and zinc. Bronze is made up of copper, zinc and tin, okay. But if you are asked to write the main metal, you have to write only copper. You cannot write any other metal, you have to write only copper. Similarly, duralumin is the alloy of aluminium. The main metal of duralumin is aluminium. But with aluminium also magnesium, manganese and copper are present, okay. But main metal is what? Aluminium. Then stainless steel is an alloy of iron, okay. And in stainless steel with iron we have nickel, chromium and carbon, all right. And at last solder is the alloy of lead. With solder we have tin also. But if you are asked to write the main metal, for solder you will be writing lead, for stainless steel you will be writing iron, for duralumin you will be writing aluminium, okay. Now solder, the another name of solder is fuse metal also, and it is used in making some electrical fittings like fuses, etc., okay. Stainless steel is used to make utensils. Brass, bronze, they are used to make utensils and like statues, okay. And like duralumin is used to make the bodies of aircraft, some light tools. You all know aluminium is a very light metal, so duralumin also used to make light tools like bodies of aircrafts, airships, etc. So I hope you understood what are the things to be studied from alloy, okay. And like we have to learn different terms like roasting, calcination, froth, flotation, pulverization, what I will be discussing in some other video. And as I said, anode needs to be periodically replaced as it is get oxidized by the oxygen liberated at the anode. This is related to this Hall-Héroult process, okay. So I hope you all have understood about mineral ore, extraction of aluminium, okay. Then reason behind adding cryolite, fluorospar, sprinkling charcoal powder over the electrolyte, then why anodes to be periodically replaced, then what are the alloys to be studied, what are the main metals to be written, what are the uses, okay. Now let me tell you few common errors, okay, while like learning metallurgy. Many of you get confused with the terms like roasting and froth, flotation, okay, because like both are dressing of ore, but froth flotation is like particularly for sulfide ore. The name of the methods or process of purifying ores, okay, I will be discussing these all methods in details in some other video, okay. Then significance of the chemicals used in the process of extraction of aluminium, often complete answer is not written. What I am saying is, like I said, cryolite, fluorospar, the importance of cryolite, fluorospar. Then coke powder, why are they important, why are they used during the extraction of aluminium, okay. So you all often fail to write it completely, so you have to be very careful regarding this, okay. Like example of cryolite, importance of cryolite is related to only to decrease the melting point, but like you must not forget that cryolite is used to decrease the melting point of alumina, okay, and as a solvent for alumina. That is the main point, and increases conductivity. Sometimes what happens is you think only one mark is there, so you write only to decrease the melting point, but you miss out the other important points like it acts as a solvent for alumina. So in these all cases we are expecting complete answers from you all. Okay children, then reaction at the cathode and at the anode for the electrolysis of alumina. Okay, please check the reaction of cathode and anode. One, see, at cathode aluminium ion is getting like reduced, okay, Al3 plus 3 electron gives aluminium, and at anode like O2 minus they are losing 2 electrons to become neutral oxygen, and O plus O2. You have to reach till O2. You cannot leave the reaction at single O because oxygen is diatomic. Okay, then see, name of the components of the alloy. Like I said, when the main metal will be asked, you cannot say many metals. Like if it is asked that like name the main metal of brass, I know that copper and zinc are used to make brass, but the main metal is copper, so you cannot write copper and zinc or even zinc. You have to write only copper. So these are the cases where you need to be very careful about answering the questions from metallurgy. I hope you understood the chapter metallurgy. For further clarification, you can contact me over like WhatsApp or mail. I'll be happily clearing your doubt. So till then, thank you. Everyone should take care and stay safe and study well.